3.6 parallel lines in the coordinate plane. We know that slope is rise over run. What does rise stand for? What does run stand for? On the Cartesian plane, what does rise stand for? Which variable do you think you're talking about when you say rise? Yes, and what? And which variable is that? Y is rise. What's the run? X. So we know that we're talking about rising Y and running X. We do have the slope formula. We also know that slope stands for M. So here is the slope formula right here. Y2 subtracting Y1. And that's what this says right here. Subtracting your Y's and then you're subtracting your X's. And we already know that we just have to go in the same direction, right? Some people like to start at the bottom and subtract going this way. Some people like to start at the top and subtracting this way. So we use the distance formula. We had the same thing, Y2 and Y1. We had the midpoint formula, so you should be pretty used to now what it means to have Y2 and Y1, X2 and X1. All right, so we know it's rise over run. A cog railway goes up the side of Mount Washington, the tallest mountain in New England. At the steepest section, the train goes up about 4 feet for every 10 feet it goes forward. So what does that mean? It goes up, you can see the numbers here, it goes up 4 for every 10 feet that it's going. So we've got our rise and run right there. We've got our slope. It says find the slope of the section. So if slope equals the change in Y over the change in X, what's the slope of this going to be? Very good. So it's rising 4. There's my vertical change for Y. And the horizontal change for X is 10. Would I leave my answer like that for slope? 4/10? No, what's wrong with it? You need to simplify it. What's the common factor I can divide out of both of those? So write down your final answer. M equals 2/5. All right, now we're given 2 points. I need to find the slope when I'm given 2 points. You've got your slope formula up top. Use your slope formula. 2 points. This means that I was given X1 and Y1, and I was given X2 and Y2. Given 2 points. Find the slope given 2 points. So I have 2 points. You shouldn't erase anything that you have because there's 2 different ways to do this problem. You could have said that this was my first point. This is my second point. You could have started by looking at it like that. Don't erase your stuff because there is 2 ways I can do this. Okay, maybe you switched your points and you said the second one was the first one. So the point is that you need to subtract your Y's. I'm going to circle my Y values, and I'm doing this 2 different ways, so don't erase. I'm going to start with doing what the formula says, where it says Y2 subtracting 1. Here's Y2 and subtracting Y1.
Turner and Sean Killian, please come to the office.
2 subtracting 6, and then my X's. 5 subtracting 0. So I could have done it that way, or I could do it the other way. I could go this way, so I just went that way. I started with the 2 and I went to the 6. 2 subtract 6, 5 subtract 0. I'm going to go the other way this time. Do I get the same answer? Y minus Y, 6 minus 2. And I need to start here again and go 0 minus 5. Can I go in either direction as long as I do both of them in the same direction? I did both my Y's going left, both my X's going left. I did both my Y's going right, both my X's going right. 2 minus 6 is -4. 5 minus 0 is 5. 6 minus 2 is 4. And 0 minus 5 is -5. Did I get the same thing? Are they the same answers? Why not? What's wrong with them? Why do you think they're not the same answer? How many negatives are on this fraction? How many negatives do you see on this fraction? Just 1, right? So I could technically pull that up front and say it's -4/5. How many negatives do you see on this fraction? So I could technically pull it out They both only had one negative. So it's -4/5. It can be in the numerator, it can be in the denominator, or I can have it out front. So my point is that you're just subtracting your y's over subtracting your x's. You need to make sure you're going in the same direction for both the y and the x. Okay, the next one. Two lines are parallel. If and only if. What makes them parallel? They have the same slopes. They have to have exactly the same slope to be parallel. All right, next page. So we got the slope formula. What else do we have here? Find the slope of each line. I'm looking at a graph, and I want to find the slope from a graph. I can find the slope given 2 points. That's one technique. Here's my second technique of finding slope from a graph. That would be rising and overrunning. I shouldn't have to write down points and do it the long way. I should be able to look at the picture and be able to find my slope. So because it's a graph, I'm not going to write down y2 minus y1 divided by x2 minus x1. I'm going to write down the slope equals rise over run. That means that my slope will equal the y value over the x value. That's what I'm thinking of when I'm looking at a graph. So let's do the slope of J1. So we're going to do M, and I'm just going to say I'm looking at J1. M, I'm looking for the slope of the line that's labeled as J1. Rise and run. Try to figure out what the slope of J1 is. What would be rising and running? Write it down. You have a pencil to erase. What would be the slope of the first line, J1? It says I'm rise over run. That means my y value over the x value. You would say that this is my rising 4, this is my running 2. And then I would just simplify. I wouldn't leave it like that. So the slope of J1 is what? What's your final answer for that one? That's right. It says 4 divided by 2, which is 2. Now I want you to find the slope of J2. All right. So tell me what your answer is for the second one, though. What'd you get for J2? Very good. 2 over 1. And so my final answer for the slope of J2 is what? All right, so we've just found that these lines are parallel. I proved that they're parallel because they got the same slope. If they get the same slope, we know that they are parallel. Parallel because they have the same slope. That's how you prove they're parallel. You find their slopes. They need to be the same. Parallel because they have the same slope. We are going to find the slope of all 3 of these lines. Yeah, they got points on them, but I don't want to use the formula. It's a graph. Let me see. This point is exactly at an exact point in the corner of the box. This one is at an exact place. Why can't I make my own triangle and say from the bottom one, I'm going to rise up to where I see that, and then I'm going to run to the point. I want you to write down the numbers that go on that triangle. How much did you rise? How much did you run? So we got K3, 2, and 1. We got the slope of K3. We got the slope of K2. And we need the slope of K1. 3 different slopes that we need to find. Brandon, what's the slope of this line right here? And then what? Almost. I like that you went like this. You rose 1, 2, 3, 4, 5 units, right? I started at the bottom and just count how many boxes it's taken. Rise 5, and then from that point, how much am I running to get to the line? You know, I didn't expect you to say -2. Why did he say -2? Exactly. When I go up, that's in the positive direction. That's why it's +5. But when I go to the left, I'm moving in the negative direction. Remember, we got to keep our signs on it then. -2. So I rose up, that's positive, walked left, and that's negative. So we have 5 over negative 2. If I find another line that has negative 5 halves, they'll be parallel. Now for the next one, when I make my triangle in the next one, I want to start on the top and go down. Because if I try to rise and run right here, it's kind of running into the next line. So I'd like to start here and go down, rise down, and then run right. I want to rise going down and then going over to the point. You'll still get the same slope if you go the other way. But it was like, it was starting to get into this other picture over here, and I just didn't want them all together like that. And I wanted to practice what it would look like if we went down and over. Thomas, did you get one of those numbers? Okay, what did you get? So very good. I'm going down. This time I'm going down. That makes this side negative 5 because I went in the downward direction. And then what did you say when you went right? 2. And now I'm moving in the positive direction, so I'd put 2. So this one happens to be rise, negative 5, and run positive 2. Okay, so it looks like those two are parallel. They got the same slope. Now we need to look at K1. Find the slope of K1. Last line. Find the slope. You can go up or down. It don't matter. As long as you start at one point and rise and run to the next point. Bree, how much did you rise on this one? I agree. Rise 6 and run. Is that it? Did you go, when you go up, is that a positive 6 or a negative 6? And when I go left, is that a positive 2 or a negative 2? Negative. So rise 6, run negative 2. This one actually simplifies. What's 6 divided by negative 2? Negative 3. Find the slope of each line. Which lines are parallel? Which lines are parallel to each other, Thomas? Very good. So you just say that K3 is parallel. Remember using your notation for parallel. K3 is parallel to K2. That's because they have the same slopes. 5 over negative 2 is the same thing as negative 5 over 2. They both only have one negative. So it's negative 5 halves. All right, so 2 things we've learned so far is we found that we use the slope formula. Slope formula. We also use the graph for rise over run. So if I'm given a graph, I'm not going to use the points. I'm just going to use rise and run. If I'm given 2 points, then I use my formula. The last thing that we need to do today is, here is slope intercept form. Y equals mx plus b. We used this last year. M is the slope. B is the y-intercept, where it's intercepting the y-axis. We need to write an equation of a line if we are given a point and a slope. So the first thing I'm going to do is I'm going to write down the formula that we're using. And then we need to substitute some things in. Out of this equation, how many variables are in this equation right now? How many? There's 4 variables. We only know how to solve an equation that has 1 variable in it. Like, say, 2x plus 3 equals 10. That's got 1 variable. If I had 2x plus 3 equals 4x minus 8, that still only has 1 variable, x. Yeah, it's true that I'd have to combine them together, but they only have 1 variable in it, x. Right now, we have an equation that has 4 variables. So we need to figure out where to put some stuff in this equation to get it down to having just one variable to solve for. Where can I put something? Very, very good. So if it says slope, this means that m equals 5. So I'm putting a 5 right here for m. I'm substituting in my m. What else do we know? We know that this is an x, y coordinate. That means that x is 2 and y is 3. So we're going to substitute those in. Y is 3, and then x is 2, and I have plus b. Now how many variables do I have in my equation? How many variables do we have now in this equation right here? We only have one. We got to solve for b. But before we start, I'm wondering what you think about what I have written down here, Brandon. I'm wondering about what I have written down here. Is it very clear about what I have written down? Are we good to go? What does it say? Tell me anything. Answer any of those questions about what I just said. Yes, that's true. Y equals 3. But looking at this equation right here, I'm just wondering about this one, Annabelle. Because it looks like 3 equals 52 plus b, doesn't it? It's not 52. It is m times x, and I did not put a multiplying sign in there. I should either put the point to show multiplication, or I should use parentheses to show multiplication. I did not show multiplication, and yet it says m times x. Okay, how do I start this problem? You need to start by simplifying first. We have 5 times 2, so we have 3 equals 5 times 2 is 10. And now I need to solve for b. So sometimes you have to simplify before you can start your solving. How do I start solving for b? Very good. It's a positive 10, so I subtract 10, and I get that b equals what? What's 3 minus 10? Negative 7. All right. We're almost done. That was the hardest part of that. That was the hardest part of that. I can write my equation now. I can use this to finish writing my total equation. If I have m and I have b, I can write an equation. Let's see if you can write an equation. If I have m and I have b, I can write an equation of a line. Do I have m? Do I have b? Then I'm going to write my equation of a line. It's y equals mx plus b. And I know my slope is 5, so I have y equals 5x. And my b is negative 7, so I just put minus 7. You don't see equations that have plus minus. My slope is 5. My b is negative 7. There's the equation of a line. An equation of a line will always have a y, and it will always have an x. That's how we know it's a line. Every time it has to have a y and an x, unless it's a horizontal or vertical line. But slanted lines, I have a question for you. Is this positive, negative, 0, or undefined slope? It's going down. Is this positive, negative, 0, or undefined slope? Can I walk on that? Yes, so that's 0 slope. What about this one? Can I walk up the wall? No, not yet. It hasn't been defined by man yet. I mean, come on. The wheel was undefined at one time. We figured out how to make a wheel. Okay, that's undefined. And how about this one? That's going up the hill. That is positive. Remember slope, dude? Okay, so here's the equation of the first line. We need to write an equation of a line that's parallel to this. What's the slope of this line? If I have y equals negative 1/3 x minus 1, what's the slope of that line? Look back at your formula. Looking back at this formula right here, it's not 2 points, so I'm not looking at 2 points. I'm looking at this one. What is the slope of this equation right here? Don't forget about the negative in front. All right. So the slope of this line is right here. It's right in front of the x, negative 1/3. I need to write an equation that's parallel to that. So what's my parallel slope going to be? If the slope of this line is negative 1/3, what will be the parallel slope? They have to be the same. So I already know the slope, negative 1/3. So I know the slope. It's going to be negative 1/3. And I have a point right here, 3, 2. It needs to go through 3, 2, and it has to have the same slope. So we have everything that we just did on the last problem. I need to write an equation. I have 4 variables, and I need to get it down to 1 variable. Go ahead and substitute in our given information. Substitute in. Let's see if you can set up your equation. Okay, we have to simplify. Negative 1/3 times 3. How do we start multiplying fractions? Make 3 a fraction. Then what? Multiply straight across. We have negative 1 times 3. 3 times 1. Is that my final answer? What's your final answer for negative 3 divided by 3? Very good. All of that work for negative 1. Finish solving for B. If I have M and I have B, I can write an equation of a line. So I would start with this. If you're struggling, that's what we're trying to use. If I have M and I have B, I can write an equation of a line. Do I have M? I do. Do I have B? Okay. Just got to substitute them in now. What do we get for an equation? So you're going to make sure that you keep your Y there. The only thing you're substituting in for now, once you find your M and your B, is just the M and B. So Y equals negative 1/3 X, and then I have a positive 3 for my B. If it's going to be an equation of a line, it will always have a Y and an X in it. Okay? All right, let's look at the homework.